If you live to see your 80th birthday, you will have spent a quarter of a century completely unconscious, paralyzed, and hallucinating in the dark. Most of us treat this massive chunk of our lives as a void. We think of sleep as a human power-down mode, a blank space where the brain goes quiet and the body simply rests until the battery recharges. But that assumption is completely backward. The moment your head hits the pillow, you enter one of the most biologically active periods of your entire day. What feels like a solid block of nothingness is actually a highly structured 90-minute repeating loop known as sleep architecture. Your biology is running a full-scale, precision-timed maintenance operation. Because we mistakenly view sleep as passive downtime, we treat it as optional. We completely misunderstand the physiological damage we cause when we force this daily maintenance shift to clock out early. This chart maps out a standard 8-hour night of sleep, broken into those repeating 90-minute cycles. Look at the early part of the night. These massive valleys represent slow-wave, deep sleep. This is when the heavy lifting happens. In 2012, researchers at the University of Rochester discovered exactly what the brain is doing down in those valleys. They found a hidden plumbing network inside our heads called the glymphatic system, which kicks into gear the moment deep sleep begins. The brain cells physically shrink. They contract to create wider gaps, allowing cerebrospinal fluid to rush in and wash out the metabolic waste products that build up while we're awake. One of those specific waste products is beta-amyloid, a toxic protein heavily associated with Alzheimer's disease. The glymphatic system clears this debris at a rate that is physically impossible to achieve while you are conscious. While the brain reorganizes itself to take out the trash, the rest of the body goes into strict repair mode. The largest daily surge of human growth hormone floods your system during these first few hours, tasked with repairing tissue, recovering muscle, and regenerating cells. Your immune system uses this exact window to produce cytokines, proteins that specifically target inflammation and fight off infections. This is why you heal faster and why your body aggressively craves sleep when you catch a virus. Even your cardiovascular system takes advantage of the deep sleep phase. Through a process called nocturnal dipping, your blood pressure naturally drops, granting your heart and blood vessels a critical period of reduced workload. The first half of the night is a mandatory physical overhaul. It is a heavy-duty, coordinated cleaning and repair shift that keeps the biological machine running and defends it against long-term disease. But let's look back at our sleep chart for the second half of the night. Notice how the architecture changes. Those deep physical repair valleys flatten out, and these expanding blocks at the top take over. This is REM sleep. We usually associate REM with vivid dreaming, but those dreams are really a byproduct of a massive cognitive processing event. This is where memory consolidation happens. The brain actively reviews the raw experiences and data you gathered during the day, organizing it and physically transferring it from fragile short-term storage into permanent long-term memory. Studies consistently show that if you sleep immediately after practicing a new task, you will perform it measurably better the next day. The brain actually rewires itself while you lie there, cementing the connections between new information and what you already know. It also acts as a form of overnight therapy. During REM, your brain processes difficult emotional experiences, strategically stripping away the raw, visceral charge attached to those memories so they are easier to manage the next day. The heavy lifting is divided perfectly. The early night builds your physical resilience, while the late hours secure your cognitive abilities and emotional stability for the morning. So what happens when you decide to set the alarm clock early and only grab 5 or 6 hours of sleep instead of 8? Looking at the structure of the timeline, the math becomes clear. Because REM is heavily backloaded toward the morning, cutting your sleep by 25% does not shave an equal portion off all your sleep phases. It selectively amputates the largest blocks of REM sleep. Your body got its physical repair during the deep sleep valleys, so you might wake up feeling physically capable of moving around. But you have starved your brain of the time it needs to secure your memories and regulate your emotions. And the actual quantity of hours is only half the equation. Quality can throw off this timeline just as easily, particularly when we introduce chemicals like alcohol before bed. A drink might help you lose consciousness faster, but alcohol acts as a chemical roadblock. It suppresses REM sleep and disrupts the later cycles. You can log a full 8 hours in bed and still wake up biologically deprived of the specific stages your brain required. Good sleep hygiene requires honoring a strict biological timeline. Securing 7 to 9 hours of rest is a physiological requirement. Your body already knows exactly how to clean, rebuild, and organize itself. You just have to step out of the way and give it the time to finish its shift.